In this demo, we shall see the use case to sync the products that got created in the ERP to Shopify and ATPDB via OCS streaming. So this use case has been achieved using the OIC, and we have used all the first class adapters for the respective applications, be it OCS streaming, Oracle ERP, Shopify, and ATP. So whenever there is a product that gets created in the ERP, an event gets generated and the same event is being captured by OIC, Oracle ERP adapter, and published into the OCI streaming using the OCI streaming adapter. And the same message can be captured by our OIC streaming adapter and then process it Shopify and ATP as well by creating couple of integrations over here. Later, in case if the customer wants a new subscriber to be consuming the same message that was created in the first step, and then they can create a similar integration to process it to the third subscriber as well. Let's now run the integration end to end. So in order to achieve this use case, I have built three integrations, one for publishing the message from Oracle ERP to OCS streaming, and the next two integrations are to subscribe the same message from streaming to Shopify and Oracle ATP. Now let me go ahead and create an item in the Oracle ERP. I've keyed in the information of the item name battery and the description ABC battery. Before I go ahead and create the product in the ERP, let me quickly check whether this product is available already in the Shopify or not. I'll just refresh it and then see. I don't see this particular product is available in the Shopify. So I'll go ahead and save the item, save and close. Right after I save it, an event gets generated from Oracle ERP, which will be captured by Oracle Integration Cloud. If I go into the observe, so I should be able to see the event that has been generated and captured by OIC. So I see the message that has come to the first integration. That means the event has been raised. Publisher integration has captured the event and then going to process it to the OCS streaming. Great. Our first integration is successfully executed, and then our subscribing integrations also is able to capture the message from the OCS streaming and process it to Shopify already. Let me refresh it again. Yes, I can see the other subscription integration, which is ATP, also got executed successfully. So now let's quickly go into the Shopify. Let me type the product battery. That's great. I can see my product which I have just created is available in the Shopify. I will also go to the ATP. So I just ran the table with the select statement. I don't see the battery product available in the ATP. Let me run the table. I can see my product that got created as a row in the ATP database table. So let's now quickly go into the design time of these integrations. I'm into the first integration, which is the publisher integration from ERP to OCS streaming. Let me quickly check the ERP trigger wizard has been configured to receive the events. So this is the basic info page. I have three radio buttons. First one is to receive the events that are raised in the ERP cloud. And the next one is to receive the messages on the callback. And the next one is to receive the messages on an explicit execution of Groovy script. This is a customized one. So let us go to the first option. ERP is by default exposing a lot of events, and all these are being shown over here in the trigger wizard. I have selected item create event, and I have an option to filter the expression. For example, I want to receive only the products that got created in a particular department. So this is the summary page. Let me finish it. Let's also quickly review the connection page of the ERP adapter. So I provide ERP host name, and we support multiple security policy, username, password, auth, code credentials, and token based PGP key. And we support public gateway and the private endpoint. And the same message I'm passing it to the OCI stream. So the OCI stream here is invoking the adapter, which is nothing but publishing the message that I have received it from the source application. So I have selected the publish message to the stream here. So I have a facility to select the stream. So I've selected one of the stream that are available in my OCI streaming. And I can also select the partition. So I've selected default partition. That means it, according to the algorithm, it goes and sits into one of the available partitions over there. We also can specify the specific message structure. You are supposed to upload the structure here, and I've uploaded the JSON sample. Continue, and this is a summary page. Let me now go into the one of the consuming integration, which is from OCI streaming to ATP-DB. So here I've used OCI streaming adapter as a trigger to consume the message. Let's quickly review wizard page. So if you remember, while publishing, we have selected one of the stream which is available in the OCI streaming. The same stream has been selected while consuming as well, and the same as partition also. So I've selected the default partition, and the next one is the consumer group. User has to mention the unique name here, and all the consumer groups will be registered in the OCI streaming to make sure all the consumers receive the same message. And you have a polling frequency as well. So according to the frequency, go and find it out whether it has any messages available to poll it and then process it further. We also have number of messages that can be fetched in a single poll. And the next option is to specify the structure as similar as publishing. You can also mention the headers if there is any. Once you select the structure, you are supposed to upload the structure in any of these format. These are the formats that we support here. Then finish. This is the summary page. Let's now review the ATP adapter wizard for the invoke. In the basic info page, I have three options to invoke the stored procedure, run a SQL statement, and perform the operation on the table. For invoking the stored procedure, in our use case, I'm using perform an operation on the table. You will have multiple options that are available to perform insert, update, or merge and select. As we are inserting the data into the ATP, I'm using insert here and continue. I can select one of the schema available there and then a table associated to it. So I've already selected a schema and the table, which is products. Continue, and this is a summary page. Once you configure both the wizards, be it OCI streaming and ATP-DB, the message structures that are available in both source and the target, you can map the required fields according to the business use case.
Hello. In this video, we'll look at how Oracle integration boosts developer productivity with pre-built accelerators. Accelerators are supported, extensible, and upgradable integrations designed to solve common business use cases. Accelerators can be found in the integration store right from the home page. Here we have an accelerator to streamline order management operations between Shopify and Oracle ERP Cloud. Installing an accelerator is as easy as clicking the Install button. The accelerator is installed in an integration project to consolidate the configuration and management of the various integration assets that make up this accelerator. One of those configurations is to define how the integrations will connect with the underlying applications, Shopify and Oracle ERP Cloud. Defining a connection typically involves specifying attributes such as the application endpoint and security protocol. And if we ever need help, we can always use our embedded conversational AI to provide some quick and contextual answers. Of course, integrations are where we orchestrate the various activities between the applications. This accelerator contains an integration to create an ERP Cloud purchase order when a Shopify order is placed, and another to update the Shopify order fulfillment once the purchase order is closed. If we look at the order fulfillment integration, we see that it starts with a trigger from Oracle ERP Cloud when the purchase order is closed. It then proceeds to get the purchase order details, get the Shopify order details, and then create the Shopify order fulfillment record. If we drill down into the Shopify create order fulfillment operation, we can see how the pre-built integration is populating the order fulfillment record with the data previously collected in the integration. This is all good, but we notice the accelerator is not using the notify customer field. This field directs Shopify to notify the customer when the order has been fulfilled. So we want to extend this integration to send the customer notification. And to do so, we simply select the Shopify Create Order Fulfillment operation and click Extend. From here, we can give our extension a useful name and then use the data stitch activity to set the Notify Customer field. We can configure the data stitch activity by finding the Notify Customer field. Now, these business objects can be very large and complex, so let's just search for the field that we want. And now we can set the Notify Customer field, indicating we want the notification sent. So all is good, and we can deploy the integration for this accelerator. So we've been successfully running our integration, and if we fast forward a bit, we see that Oracle has released an update to this accelerator. We can install the upgraded version as we did before with a single click. And if we look at the project, we see there is a new version of the fulfillment integration. Of course, it was the 1.0 version that we extended, but if we open the new version, it automatically detects our extensions and prompts us to merge them. Looking at the details of the new version, we see indeed our extension has been merged. So give our new accelerators a try to increase developer productivity and start automating your business. Thanks for watching.
In this demo, I'll be demoing the process of automating the contract to procurement workflow using our brand new adapters, SFDC REST and COPA, which are recently developed in our OIC. Along with these adapters, I'm also using another application called DocuSign to sign the contract. In order to integrate DocuSign, I'm using DocuSign adapter. Let's now see the step-by-step process, how it is being achieved. Right after there is a contract that gets created in the Salesforce, an event gets generated to OIC, and OIC captures the event and sends the information, the contract information and the contract document to DocuSign for the signing to be done by the approving authority. The DocuSign send an email to the approving authority and waits for the approval. Once the approval comes back, DocuSign responds back to Salesforce with the contract signing status. Here, if you observe, the step number 2 and 3 are marked with the separate colors. Here, we are not using OIC for the contract signing because that's the internal process of DocuSign. But in order to send the document to the DocuSign, we are using our native adapters, DocuSign adapter and Salesforce adapter for step number 1 and 4. The next one is upon receiving the contract status that has been successful, Salesforce generates one more event and the OIC captures that event to create a supplier in COPA. Once the supplier has been created in COPA, COPA responds back with a supplier ID which has been fed back to Salesforce application. So let me create a new contract. So I have a account which is called ABC Corp, and I select an employee which belongs to ABC Corp, and file upload at this point of time is false, and I'm the approving authority in DocuSign, and the status is draft. Okay, and I can write some terms for the contract. Okay, let me save it. Contract has been saved. Go to notes and attachments. Let me attach a file for the contract. So the file has been attached. Let me edit the contract and make sure that file upload is true. Okay. With this true, it goes ahead and trigger the event. Yeah, now you can see the message has been received by OIC. It has sent the message to DocuSign, and DocuSign will be sending a note to me as I'm the approver. If you see in the contract, you can see my approval email ID is there. Let me check whether I have received any email or not. I've got an email from DocuSign for approving. So let me review this document and approve it. Continue, signature, finish. So I've signed the document. So that means this update should go back to OIC and process it further. the first integration has been successfully completed. With this, it go ahead and trigger the second integration, which is Salesforce to, the Cowpa. So the message has come already from the Salesforce to OIC. The event has been captured and processed to Cowpa as well. So let us see whether the supplier has been created or not in the Cowpa. So what is the supplier name that we have created? ABC Corp is the account name. Then let me go back to Cowpa and see it out. Yeah, you can see ABC Corp is created over here. I will also double check what is the Cowpa ID, because the Cowpa ID goes back and then appended in the contract. So the Cowpa ID is 930. I'll go back to Salesforce and then see whether the Cowpa ID gets updated over here. Oh, good. You can see the Cowpa ID has been updated over here with 930. Now let's see how this has been implemented in OIC. I've created two integrations, one for Salesforce to DocuSign and the other one is Salesforce to Cowpa to create the supplier in Cowpa. So let's quickly see how this has been achieved in the first integration to get the document signed from DocuSign once the contract has been created in the Salesforce. So this is a Salesforce trigger. Right after the Salesforce receives the event that the contract has been created, it reaches to OIC. In the trigger message, it has only limited information. With that limited information, it goes and gets the attachment and it needs to process the attachment to the DocuSign in this particular scope. So it's sent the document for the signing, and I have got a while loop because it needs to wait till the approver signs the document. So it checks the status every 10 seconds or so, the document has been signed or not. Okay, once the document has been signed, it gets the response back from the DocuSign. OIC goes and updates the status back into the SFDC, saying that we have received the document signed. And now let's go to the next integration. This one is Salesforce to Cowpa. So right after we receive the document signed from the DocuSign, there is one more. An event gets generated from the Salesforce to create a supplier in the Cowpa. So once the event has been received by OIC, make one more invoke to Salesforce to get more information about that event. And with all that information, it goes and creates a supplier in Cowpa by invoking the Cowpa adapter. Upon receiving the Cowpa ID, it goes back to Salesforce to update the ID as well. As part of 2404 Oracle integration release, we have shipped two AWS services adapter, which are AWS SQS and AWS S3. These adapters help OIC to integrate other AWS services seamlessly. So let's quickly go through these adapter features. So as of now, SQS adapter supports Invoke. It supports operations such as create, delete, list, purge, tag, and untag of the queues. Enables service send, delete messages from the queues, modifying and retrieving the queue attributes such as visibility timeout, maximum message size, etc. And it enables the dead letter queuing. It supports Amazon signature version 4 security policy. And in upcoming releases, we were planning to support XML messages to and from the queues and inbound polling and the connectivity agent. From the S3 adapter perspective, this adapter also supports inbound connectivity, supports objects and buckets of the storage entity. Suppose put, copy, get, delete operations, and list. Allows attachments, and then it supports Amazon signature version 4 security policy. As part of the future support, we're going to support connectivity agent. Let's now review the use case for today's demo. So the use case is to demonstrate the OIC's capability of multi-cloud integration. So we have Primavera Cloud on OCI and AWS SQS and PostgreSQL on AWS Cloud. Using OIC, we'll be integrating all these applications across the multiple cloud infrastructure. So OIC extract the activities of a project from Primavera Cloud and then publish the activities to the AWS SQS. OIC consumes the messages that are available in the AWS SQS and then insert the activities into PostgreDB, which is hosted on the AWS.
Let's now go into the OIC and see how this use case is achieved using the Oracle integration. So as I mentioned, I have two schedule-based integration, one to extract the project details and activities from the Primavera Cloud to SQS, and the other one is to consume the messages from the SQS queue and then post it to PostgreSQL. So let me first execute schedule-based integration to extract the project activities. Before I run this integration, let me go into the AWS SQS queues and then showcase whether we have any messages that are already available in this particular queue. So I'm using this Primavera project activity queue.fifo for our integration. So let me click send receive message. I see there are no messages available over here. So let me go ahead and execute the integration. So I've given the project ID as an input here. I can see the message successfully executed. Let us now go inside the SQS and then check whether we have any messages that are available here. I will click send receive message. I can see one message is available over here. So let me poll this message, take the content of this message, and it has two activities. Now let's run the second integration to consume the message from the SQS, which we have just inserted using the first integration. So before I go ahead and run the second integration, let me take you to the PostgreSQL. So this is the table which I'm using to insert the data. So let me run this one. I see there are no messages available. Let me go ahead and run this integration. I can see the message successfully processed. Let's go to PostgreSQL, run this particular query again. We have seen two activities in the message, and I can see two rows that got created in the PostgreSQL. So one more important point to note here is right after the messages got posted into the PostgreDB, we are deleting these messages from the SQS queue as well. So let me do a poll message. Currently you see one, and now the integration successfully executed. So I'm polling the message again here whether it has been deleted or not. I can see zero messages that are available. Let's now see the design time of this integration. So this is a schedule based integration. I'm invoking Primavera Cloud adapter to pull the activities of a project, and I'm invoking SQS adapter to send the message to the SQS queue. So let's quickly go through the SQS adapter. It has multiple resources: queue administration, message move task, and permission. I've used message resource over here to send the message. It has multiple activities: receive, delete, send, and change message visibility. So right after you select the send message, it'll ask you to select the queue to which you wanted to send the message, and this is dynamically be populated as per the connection configuration that you have done. You can upload the JSON sample over here. You can even encode the message, and you can configure message attributes. The same way, you can even receive the message, and once your activity has been completed, you can even delete the message if required. You also have dead letter queuing option in case if there is any message that got stuck due to the network issue or any other issue, so the message was not pulled from the actual queue, it goes into the dead letter queue, and you can design one more integration to move the message from dead letter queue to the actual queue. So you can provide source ARN and the destination ARN, move the dead letter queue message back to the original queue so that actual integration can again pull the message from here. So let us go into the other integration. As you know, this is also schedule based integration. Here we are using SQS adapter to receive the message. In the previous one, we have sent the message. So hence I have selected the receive message action over here in the message resource, and I'm invoking the PostgreDB. So I'm inserting the data into the PostgreDB here. So I've selected the table. It is more or less similar to other database adapters, and then posted the message. And as I mentioned, after I post the message successfully into the PostgreDB, I'm invoking one more action of SQS to delete the message from the queue. Let's also quickly review the SQS adapter. You should have to provide the AWS region. We support AWS Signature version 4 security policy. That's all from our demo today.
Hello everyone. As part of this demo, we are going to take a look at Courier to Slack pre-built solution. This pre-built solution demonstrates how one can interact with Courier using Oracle integration platform. We have built this solution on a web-based Courier adapter. We have leveraged Courier through OIC here and created a contextual experience in Slack. We'll take a look in a moment how a user is asking a question and getting a contextual response. And we have demonstrated how to use webhooks through an OIC. So with that, let's quickly take a look at this overall flow and then let's get into the demo. So as part of this flow, we will start with asking a general query from a Slack, and query can be anything. Query can be something like, when is the next blue moon? When is the next Cricket World Cup? Anything. And as the query is received by the Slack, the query shall be forwarded to OIC via the webhook, and as OIC receives it, it shall forward the query to Courier, invoking the generate API. Courier, on receiving the query and response from the generate API, shall invoke the another flow on the OIC side, which in turn will respond to the Slack thread, and user will receive a contextual response on a Slack. So with that, let's get on to the practical demo. Okay, so here we are demonstrating the Courier to Slack pre-built solution. So as part of the pre-built solution, the first thing is we have created a bot named as Aura app, and with this bot you'll be able to ask any question. You could start with, what is Oracle Integration Cloud? And as you ask a question to a bot, there is a webhook registered on a Slack site. We'll talk about that also later on, which basically receives the command and then, as we discussed earlier, gets the response back from the courier and post it back to the Slack. So if I go back, I can see that we have successfully received a response over here. Now, if I take a look at the pre-built solution, here is a pre-built solution. If I go to the observability, I'll be able to see that the flows have executed. So you can see here the flows have just now executed, and this flow essentially, if I click on this, has first received an query from the Slack. So if I look at the activity string, here it is, I can see the query over here. And as this flow was processed, later on another flow came in which received the response from Courier, and that response was forwarded to the Slack thread. Now, this solution can be used for invoking any API that you would like to invoke on the Oracle integration platform from Courier point of view. Another thing to note here is we have used a RAB adapter for this solution. So if you see here, we are using the RAB adapter. So this adapter was built on RAB framework, which improves drastically how one can build the adapters for the endpoints for which we do not have out-of-the-box adapter. RAB stands for Rapid Adapter Builder. So using just the API definition, you could build the adapter and then leverage them in your solution like a first-class citizen adapters which are shipped out of the box. You get all the good things as you have built it. You get the mappers and everything else that you are having along with the core adapter. Okay, now let's take a look at the solution design point of view. So as part of this solution, you can see the first flow, which is receiving an event from the Slack. And if the event is received, it is forwarding the request to the another integration, which is used for processing the job. So this is the simple flow that we have created. And let's now take a look at the another flow. So as part of the second flow, this is where the main job is happening, where we are basically taking the question and forwarding that particular question to Courier, getting the response, and then posting that response back in a thread. As you can see, we have used the RAB adapter over here, and we are invoking the generate API. As discussed earlier, this generate API is provided by the Courier. So we have used this generate API. Similarly, one can use any other API from the adapter as you want. by the Oracle integration platform, and you could all do all these things on a web-based adapter. So that would further elevate the experience. Now let's quickly talk about how we are basically registering the bot. Now for bot app, what we have done is we have used the Slack configuration. So over here, we have created a bot app and we have configured the feature and functionality. Like say we want to subscribe to an event. I'm not going to go too much in detail, but this just to share that this all functionality we have used. So you could also use it and create a more contextual experience. And here you have provided your instance URL. You could provide more contextual experience for your customers. Now to summarize, as part of this solution, what we did was we configured the pre-built solution. That is, we saw how to configure the webhook on the Slack and things like that. Typically, it will involve something like you install the pre-built solution, you will configure, and then you will leverage the pre-built solution. So as part of this use case, what we saw is that how we could take a query and forward that query to Slack through OIC and then receive response back from Courier and pass it back to Slack. Now this can be used for a variety of purposes, something like improving the service request experience through generative AI. Imagine that you have so many common issues that you have already resolved. So generative AI can generate the appropriate response, and Slack is something that your service team already uses. So you could all automatically just plug it in and make it available to them. You could use generative AI as part of your core business processes and stuff like that. So with that, I conclude my demo. Thank you so much for your time. I hope you found it useful. Today, we are going to demo the warehouse management inventory cloud pre-built solutions. So as we have been working with multiple SaaS teams, we have a lot of pre-built solutions which are available on the Oracle integration solution. And today, we are going to look at one of them. So as part of this whole venture, warehouse management team and inventory cloud team have created three pre-built solutions recently. One related to the inbound operations, another one related to the outbound operations with scenarios like receive, inspect, or pack and ship and stuff like that. And the third pre-built solution, which we are going to demo today, is related to the inventory transactions, where user might do some inventory adjustments, or as he receives the LPN, he creates the LPN or modifies it, all those things. So let's quickly look at the pre-built solution. Okay, now here we are on the Oracle integration instance. So right on the home page, we can see that one can access the pre-built solutions, that is recipes and accelerators. Now, if you click on view all, you will see there are a lot of pre-built solutions that are available out of the box. As we can see, there are 192 available right now. Now, the one which we are interested today is between the warehouse management and inventory cloud. So I can simply type WMS and press enter, and I can see there are 5 solutions available. So for today, we are focusing on this instance. To get this solution, all I need to is just click on get. As I click on get, I will see that project has been installed. I can click to go onto the project screen where this solution will be right on the top. So if I open up this solution, I can see this solution includes integrations, connections, lookups, libraries, all at the one place. Now to save the time, I've configured the connections and I've activated the flow. So the way this integration works is we'll create the LPN entry on the warehouse management, and it will see that the updates done to the inventory is synchronized back with the ERP cloud. So let's now proceed with the demo. So here I am now in the warehouse management web interface, where I'm just using kind of a mobile device to scan the inventory LPN and then create. What I'll do, I'll get into the inventory, and in the inventory, I'll say I'm creating the LPN. I'll give an LPN for my item, just that which I can correlate to, and I will punch in the item. So, and I'm entering the quantity. As I've done it, I will end it and I will give the location. Okay, as I've saved the location, this has now created the LPN. Let's now go to the warehouse management interface. Now, okay, here we are on the ERP Cloud instance. We have searched for an item, and if I select the item and say view the item availability, I'm seeing that item availability is 100. Now let's go to the warehouse management and see if the transaction has been synchronized. And we'll see that 20 item will basically impact it. So it should become on hand 120. So let's go to the warehouse management. Okay, here I am on the warehouse management side. I can see that entry has been created, but those are not yet been synchronized with the ERP cloud. So there is a schedule which is defined that everybody will define based on their needs. I have set up a schedule based on it. It will automatically should pick up. So let's wait for some time and we will check it again. Okay, here we are now. Fast forward 5 minutes and we can see that entry has been processed successfully. So if I now go back to the integration cloud, I can see on the integration cloud that the instance has uh, executed. So if I just refresh it, I would see it has executed now. So the idea here is that we have a schedule of 5 minutes. So that's where you can see the difference of 5 minutes and they have executed successfully. Now, if I go to the inventory cloud and just refresh the item by just selecting the, okay, I can see here already it is showing 120. So this basically shows that as I did the transaction on the warehouse management, the flow executed and it synchronized back. Similarly, if I make any edits, those will also be synchronized.